Welcome to the Preventive Maintenance Application demo. Step 1 is to find the app in GCP Marketplace. Go to the Marketplace and search for Preventive Maintenance. Select the Preventive Maintenance ML solution deployed by Pluto 7. This solution predicts the remaining useful life of the machine. So before clicking on Launch on Compute Engine, you need to enable a few APIs on Google Cloud, which is step 2. To do that, go to Google Cloud Console. Go to APIs and Services. Click on Enable APIs and Services. These 6 APIs are essential for the solution to work, so make sure you enable them all. The first one is Compute Engine API. Second is Cloud Storage API. Next, you need to enable Cloud Auto ML API. Fourth one is AI Platform API. The next one is Google Cloud Storage JSON API. The last one is the Deployment Manager, which allows us to deploy the solution from the marketplace. Now that you have enabled these 6 APIs, we move on to step 3 to deploy the solution. Go back to Preventive Maintenance ML Solutions page from step 1 and click on Launch on Compute Engine. Scroll down and check the box to allow HTTP traffic from the internet. Then click on Deploy on each button. Post the solution, we'll set up the necessary cloud services. It takes about 2 to 3 minutes to set up the application since we're using Google Cloud Storage and Compute Engine. On the right side, you can locate the default login credentials. Now the solution has been successfully deployed. Moving to our 4th step. To launch the solution, go to Compute Engine and select VM Instances. In the VM Instances page, you can locate Preventive ML VM. To access it, click on External IP. Initially, the application will install all the acquired dependencies. It takes about 2 to 3 minutes after the solution is deployed. Remember to make sure that in Firewall, low HTTP traffic is enabled. To enable it, click on Edit and check this box. Then save the changes. By now the application will be ready to be accessed. Click on External IP and log in with your default credentials. This is the home page of the application consisting of 3 sections: Datasets, Data Experiments, and ML Experiments. This brings us to step 5, uploading our own datasets. First, click on Upload Dataset. In the application homepage, go to Google Cloud Storage. The bucket name starts with project name -PM objects. Click on this bucket. Within the bucket, the sample dataset folder contains the sample dataset and another dataset used for testing the prediction. Here is how you download the sample dataset. This dataset can be uploaded here. The time required to upload the dataset depends on the size of the particular dataset. Once the dataset is uploaded, to perform any ML experiments, you need to map the dataset. Here you can see a preview and summary of the dataset. Click on Data Mapping to map the dataset. Select the respective columns. Our required output is the remaining useful life, so select RUL and then click on Submit. Click Done. Our next step is to create data experiments. select Data Experiment, click on Create Experiment. After giving the experiment a name and choosing the mapped dataset, click on Create. Here you can see a summary. In the data experiment, all the transformations are applied to the uploaded file, which are required to train a model. Once the model is completed, all the applied transformations can be located on the right side. In typecasting, all the data should be in numeric records, hence all the strings are converted to numbers. Convert Categorical finds the categorical variables in the dataset, does label encoding, and stores encoding data in the backend. Columns to drop lets you suppress the columns in the dataset which are not required for the model training. And the last, missing values, uses basic statistical analysis to find out the missing data with mean values. In the visualization section, you can see the data distribution for the columns. This brings us to our next step, creating ML experiments. In the application homepage, select ML Experiments and click on Create Experiment. Give this experiment a name. Choose the data experiment, which is complete for the dataset. Choose RUL model for the current situation. In zoo type, AutoML uses Google Cloud's API to train a model, and Pluto 7 uses our own model to train the dataset. Choose Pluto 7, click Create. Model training duration depends on the size of the dataset. With our current dataset, it takes around 6 to 10 minutes. Once the job is queued, you can see the job in AI platform. Here you can see the latest ML experiment that was created. Click View Logs to get a glance at the logs. Once the model is trained, we can go back and check the updated status. Sometimes it takes a while for the status to get updated. Now the status has changed to trained. We can go ahead and check the output of the experiment. This graph demonstrates the model performance. The blue area indicates the training loss. The brown area indicates the validation loss. Model metrics can also be analyzed here. Once the model is trained perfectly, we can move to our next step to create predictions. For the sample dataset that we provided, download the associated prediction test dataset. Click on Create Predictions. Name the prediction and upload the file. Submit this dataset. Depending on the dataset, the prediction might vary. So to see the complete version, click Download Prediction, which will show you the remaining useful life of the machine.